Hello to everyone and welcome to this American Welding Society webinar. Right now I'd like to introduce today's presenter, Dr. Richard Campbell. Dr. Campbell is a Bechtel Fellow and a welding technical specialist with Bechtel Corporation, instrumental in assisting the company's welding program to receive the AWS WEMCO Excellence in Welding Award for the large business category in 2015. Now, Dr. Campbell provides technical direction to the company and its executives in areas related to welding and metallurgy. After earning a BS degree in welding and mechanical engineering at Latorno University and a PhD in materials engineering from RPI, he has worked for nearly 40 years in the welding industry. Richard is an AWS, SCWI, and CWE, and ASNT Level 3 Visual Testing Inspector, a Level 2 Certified Welding Inspector with the Canadian Welding Bureau, and holds a PE license in metallurgy engineering. He is an AWS instructor and has taught the AWS CWI classes for over 20 years. Dr. Richard Campbell, welcome to today's event. And with that, I'm going to pass things along to you to get us started. So Dr. Campbell, go right ahead.
Welcome to the AWS-sponsored webinar on the new updated AWS D1.1 structural welding code for steel. During this time, we will review what is new in this updated edition, including the major revisions from the 2015 edition to the 2020 edition, plus editorial updates that might be of importance. Like all AWS codes and most AWS standards, the D1.1 2020 edition is an American national standard. It was prepared by the AWS D1 Committee on Structural Welding, comprising some 40 volunteer members. It is published by the American Welding Society. The foreword of the code is a great starting point for identifying changes in the code through time. The foreword provides a history of the code along with a summary of changes made in various editions. For example, the D1.1 was first published as the Code 1 Part A Code for Fusion Welding and Gas Cutting in Building Construction in 1928. This new revision is the 24th edition of what since 1972 has been called the D1.1 D1.1M Structural Welding Code Steel, now published in 2020. The foreword explains that changes in code requirements throughout the text, tables, and figures are identified by one of two methods: underlined text, such as shown in the new words in the paragraph, or a vertical line in the margin of a table or figure as illustrated by the vertical line in the top left of this page from Figure 5.2, a pre-qualified partial joint penetration groove welded joint detail. A 100,000-foot level overview of changes in the 2020 edition include a reorganization by adding two new clauses of Clauses 2 and 3, along with a lot of editorial changes to the layout of the code, including moving Clause 8, Strength and Repair of Existing Structures, to Clause 11, new parts within some clauses to better describe those sections. Like other newer AWS standards, this is presented in a single-column format, and some US and metric tables have been combined into single tables. Note that these US metric changes will not be specifically discussed. Included in the foreword is a table of summary of changes in the 2020 edition, as presented in the next 4 slides. Rather than read through these slides, we will quickly review them, then discuss in detail in later slides. The major changes to clauses 2 through 6 are identified in this slide. Major revisions to clauses 7 through 11 are discussed in this slide. Again, we will go into more detail in a few minutes on each of these. This slide identifies changes in normative annexes A through H. Note that many changes in annexes are re-identifications and relocations. Changes to informative annexes J through T are explained in this slide, along with addition of a commentary on the new Annex H on phased array ultrasonic testing. The table of contents provides the 11 clauses in the 2020 edition, compared with 9 clauses in the 2015 edition. Each of these clauses, including revisions in each, will be reviewed in the next slides. For now, it is sufficient to identify that the code is comprised of Clause 1, General Requirements, Clause 2, Normative References, Clause 3, Terms and Definitions, Clause 4, Design of Welded Connections, Clause 5, Prequalification of WPSs, Clause 6, Qualification, Clause 7, Fabrication, Clause 8, Inspection, Clause 9, Stud Welding, Clause 10, Tubular Structures, and Clause 11, Strengthening and Repair of Existing Structures. In Clause 1, the only substantive change is in paragraph 151, Engineer's Responsibilities, where the list of 9 items that the engineer shall specify in contract documents clarifies that the extent of verification inspection, when required, be identified. A new item is that the engineer must specify which welded joints are loaded in tension, as there are differences in some criteria based on the loading condition. Another change is that the latest edition of AWS A24 standard symbols for welding, brazing, and non-destructive examination is referenced rather than the 2007 edition as was referenced in the D1.1 2015 edition. The main reason for this is the change in AWS A24 2012 edition to the symbols for depth of groove from S to D and groove weld size from E to S. Clause 2, Normative References, is a new clause that was added to meet requirements in AWS TSD 1.1 Specification for Preparation of AWS Draft Standards. This is to align all AWS standards. This requires normative references to be identified in Clause 2 and provides specific wording as an introduction to this clause as shown. The references are to the latest editions of these standards, unless specific date references are included. Note that this new clause replaces existing paragraph 1.9 and some of Annex S. Note also that Annex S still exists, but is limited to a list of reference documents, while Clause 2 provides a list of references that are normative or required by the code. Clause 3, Terms and Definitions, is another new clause, also to meet requirements in AWS TSD 1.1. This replaces old subclause 1.3 and old Annex J. The lead-in paragraph identifies that AWS A30M A30 Standard Welding Terms and Definitions provides the terms and definitions used in this code. However, terms in D1.1 are identified in Clause 3 where 1. They are general terms compiled by the AWS Committee on Definitions and Symbols, or 2. Terms defined by the Structural Welding Committee pertaining to ultrasonic testing and designated with UT, and 3. Other terms identified by asterisks that are defined as they relate to this code. Only a few new terms were added or definitions revised. By adding new clauses 2 and 3, all later clauses have been increased in number by 2 compared with the 2015 edition. There were no substantive changes to Clause 4 on design of welded connections, which previously was Clause 2. However, the 6 figures in the old Annex A on effective throat were incorporated into Clause 4. Clause 5 on Prequalification of WPSs, previously Clause 3, was restructured to follow a normal progression of writing and following a pre-qualified WPS. It was split into 8 parts of Part A, WPS development, Part B, base metal, Part C, weld joints, Part D, welding processes, Part E, filler metals and shielding gases, Part F, preheat and interpass temperature requirements, Part G, WPS requirements, and Part H, post-weld heat treatment. This provides a very logical flow. There are very little substantive changes made to this clause. If one is looking for a table in this new edition and knew where it was located in the 2015 edition, most have been moved to align with the restructuring in this clause. For example, pre-qualified WPS requirements and essential variables for pre-qualified WPSs were previously in tables 3.6 and 3.7, but are now in tables 5.1 and 5.2. Base metals and filler metals were previously in tables 3.1 and 3.2, but are now located in tables 5.3 and 5.4. Minimum pre-qualified PJP weld size was in table 3.5, but is now in table 5.5. Filler metals for weathering steels was in table 3.4 and is now in table 5.6. A new table 5.7 was added on pre-qualified WPS shielding gas options for GMAW electrodes conforming to AWS A5.8. We'll discuss more on this in a few slides. and the table on minimum preheat and interpass temperatures was moved from Table 3.3 to Table 5.8. Likewise, the figure layout in Clause 5 Prequalification of WPSs was changed. The pre-qualified CJP groove welded joint details were moved before partial penetration from Table 3.3 to Table 5.1, with pre-qualified PJP details following in Table 5.2 moved from Table 3.2. Pre-qualified fillet weld details were moved from Figure 3.5 to Figure 5.3, and pre-qualified skewed T-joint details from Figure 3.4 to Figure 5.4. Pre-qualified CJP groove, T, and corner joint details was Figure 3.6, but is now Figure 5.5. Finally, the weld bead depth and width figure was Figure 3.1, but has been moved to Figure 5.6. Table 5.2, Essential Variables for Pre-Qualified WPSs, was editorially renamed and reorganized to better list WPS essential variables. This table consolidates variables into two categories: those required to be included in a pre-qualified WPS on the top, and a more easily understandable list of variable tolerances for pre-qualified WPSs on the bottom. Some new base metals were added to Table 5.3 on base metal and Table 5.8 on preheat temperatures, and some strength requirements were updated in Table 5.3. A new paragraph 563 bullet 4 plus new table 5.7 address GMAW shielding gases acceptable for production welding using pre-qualified WPSs and AWS A518 filler metal. These gases include argon CO2 mixtures, argon oxygen mixtures, and 100% CO2. New Clause 6 qualification was previously Clause 4. Revisions include requirements for qualification of WPSs using waveform technology. Paragraph 685 addresses the essential variable of heat input when Sharpie V-notch testing is required by the contract. This now addresses three methods of calculating heat input depending on the welding equipment. For non-waveform controlled welding, any of equations 1 through 3 in the next slide can be utilized, but for waveform controlled welding, only equations 2 or 3 can be used. In paragraph 6851, equation 1 is the age-old heat input calculation of amps times volts times 60 divided by travel speed. The new equations 2 and 3 are total instantaneous energy and average instantaneous power. These require meters or equipment that can sample at high frequencies to measure these values. Paragraph 6852 addresses a new requirement that the maximum heat input for a multiple position WPS has to be established by the PQR with the highest heat input. Methods for measuring total instantaneous energy or power are described in new paragraph 6853, where the power source and wire feeder have to display total instantaneous energy or average instantaneous power using one of three methods: 1. Meters or displays in the equipment; 2. External meters that can measure at high enough frequencies; or 3. Upgrades to the equipment to allow these measurements. Paragraph 6.9 addresses WPS requirements for production welding using existing non-waveform or waveform WPSs, but with the other type of equipment. WPSs qualified with non-waveform controlled power sources using equation 1 may be used with waveform controlled equipment, provided the WPS is revised to require heat input using equations 2 or 3 on production welds. WPS qualified with waveform equipment can be used for production welds using non-waveform equipment, provided the heat input using equation 1 doesn't exceed the heat input from equations 2 or 3. The retesting requirements for WPS qualification have been clarified. This requires retests on 2 additional test specimens in accordance with option 1, use of material from the original coupon if adequate material exists, or option 2, making a new test coupon but just for the test specimens that failed. Finally, for material thicker than 1.5 inches, when multiple test specimens were required to represent the complete thickness, Failure of a specimen representing a portion of the thickness requires retesting of specimens representing the complete thickness. The procedure qualification requirements in 612 for partial joint penetration groove welds have been expanded to allow 3 options, plus details for flare groove welds. 1. Use of a CJP WPS qualified by testing to support a PJP WPS using any Figure 5.2 PJP groove detail. 2. Use of a CJP WPS qualified by testing to support a PJP WPS using a joint detail not shown in Figure 5.2. Or 3. Qualification of a PJP WPS not supported by a CJP WPS. And 4 addresses qualifying flare groove welds. All of these PJP groove weld qualifications also qualify fillet welds. 612.1 then addresses Method 1 where a CJP WPS qualifies PJP groove welds conforming to Figure 5.2. 612.2 addresses Method 2 where a CJP WPS qualifies PJP groove welds not conforming to Figure 5.2 and requires determination of the maximum PJP weld size with a test plate made in accordance with Figure 629 Detail A with 3 macro edge cross sections taken. 612.3 explains Method 3, which is an actual qualification test on a PJP groove weld coupon per Table 6.3 involving macro etch, tensile test, and bend test coupons. 612.4 addresses new requirements for qualification of PJP flare groove weld WPSs by making a test plate in accordance with Figure 629 Detail B or C and taking 3 macro etch cross sections and determining the maximum weld size. All Sharpie V-notch testing requirements have been added to Table 6.7, so are in a single place. The PQR Supplementary Essential Variables Table 6.7 has been updated to include electroslag and electrogas welding in the right-hand column. Part D of Clause 6 was reorganized to better align testing procedures and qualification with Sharpie V-notch specimens with the order they would be accomplished. Part D covers requirements for CVN toughness testing and is now broken into 4 main divisions, beginning with 626 General CVN testing, then 627 CVN tests, including details on the specimen, notch location, test temperature, subsize specimens, and acceptance criteria. 628 addresses combining self-shielded flux cord arc welding with other welding processes in a single joint where there are concerns with the effects of self-shielded FCAW on toughness. This includes filler metal variables, welding of test plates, CVN specimen location, and acceptance criteria. Finally is 629 on reporting of test results. Table 614 on CVN test temperature reduction was revised. Table 615 on Sharpie V-notch test acceptance criteria for subsize specimens was updated, and a new Table 616 pertaining to filler metal essential variables for self-shielded FCAW substrate root pass welds added. Figure 628 on CVN test specimen locations was better clarified, and new figures 630 through 632 on intermix CVN test specimens for self-shielded FCAW were added. The previous Clause 5 is now Clause 7, Fabrication. While no parts were added, 7.1 scope now groups requirements in this clause into 6 groups of 1. Materials, 2. Processes and WPSs, 3. Weld details, 4. Weld quality and repairs, 5. Member dimensional tolerances, and 6. Post-welding operations. The only significant change to Clause 7 is to welded restoration of base metal with mislocated holes, where 7.25.5 was revised. This now addresses if the contract requires these holes to be filled with weld metal and requires the contractor to prepare a qualified or pre-qualified WPS and identifies 4 bullets. 2 of these have changes in them. In 1, it better identifies for base metal not in tension zones of cyclically loaded members, along with NDT requirements, and 2, addresses base metal in-tension zones of cyclic load members and provides requirements. Clause 8 inspection had been Clause 6. The inspection personnel qualification requirements were revised significantly. In 8141, it more clearly identifies the engineer's responsibilities for specifying inspector qualifications. 8142 now provides more options for visual inspector qualifications by 1. Adding senior CWI to CWI, 2. Clarifying Canadian Welding Bureau certifications as level 2 or 3, 3. Allowing qualification as a welding inspector or senior welding inspector to AWS B5.1, 4. Allowing qualification as a visual testing level 2 to AS&T, S&T, TC1A, or CP189, as well as retaining 5. An individual with appropriate training and experience in metals fabrication, inspection, and testing who is competent to perform inspection of the work. 8143 now allows for alternative inspector qualifications that must be specified in contract documents, along with requirements for documentation of this. 8144 and 8145 have similar but not identical requirements for assistant inspector qualification, such as being a level 1 rather than a level 2 visual testing inspector. The eye examination requirements in 8146 have been updated to include both visual testing inspectors and NDT personnel, plus revision to more closely correlate with the CWI requirements in AWS QC1 and AS&T S&T TC1A, such as natural or corrected near vision acuity in at least one eye of JIG or J2 at a minimum of 12 inches. Alternatives are now allowed as determined by ophthalmic medical personnel. Clause 8 Inspection, Part E Radiographic Testing has been updated to specifically allow digital radiography. 816.1.1 addresses both computed radiography, CR, and direct radiography, DR. Other paragraphs in Clause 8 were added to specifically address digital image sensitivity range, linear reference comparators, DR equipment, and digital image archival. Other changes in radiographic testing include limitations for geometric unsharpness being added, plus revisions to the geometric unsharpness equation in 817.5.1 to match ASME Boiler and Pressure Vessel Code Section 5. New paragraph 817.5.1.1 provides maximum limitations on the geometric unsharpness values. Table 8.5 on wire image quality indicator requirements was revised to reflect essential wire identity in lieu of maximum wire diameter. In Clause 8, Part F on ultrasonic testing, the methodology to determine attenuation factors was updated to reflect that UT instruments are now capable of reporting a decimal value for decibels, such as in 825.6.4. A new Annex H on phased array ultrasonic testing was added, and this will be discussed later. The stud welding clause was moved from Clause 7 to 9. Requirements were added in 92.1.1 for the manufacturer's permanent identification on headed studs and deformed anchor bars. There were no substantive changes to the normal drawn arc stud welding requirements. However, there were significant revisions made to requirements for fillet welding of studs if the contractor chooses to use these. 955 addresses use of either pre-qualified or qualified WPSs per Clause 5 or 6. 9552, Item 2 addresses that stud materials are considered Group 2 materials per Table 5.3 for selection of matching filler metal strengths. 9553 addresses base metal and stud surface cleanliness. 9554 addresses the stud fit, and if the gap is greater than 1/16 inch, the fillet weld size shall be increased. 9555 allows use of tack welds. 9558 requires welders to be qualified per Clause 6 or 10, and 9559 addresses repair of fillet welds. Other requirements from the 2015 edition, such as fillet weld size, remain unchanged. Clause 10, Tubular Structures, had been added as Clause 9 in the 2015 edition to combine all tubular requirements into one clause. The scope of Clause 10 clarifies the term tubular connections to include butt joints between tubulars, TY and K connections of tubulars to tubulars, or tubulars welded to flat plates or flat elements. It includes rectangular as well as square tubulars together. 10.1.1 clarifies that tubular members include 1. Circular hollow structural sections termed HSS, 2. Rectangular HSS, 3. Square HSS, as well as 4. Fabricated members from plates or shapes joined with CJP longitudinal seam welds. The calculations for static strength of welded tubular connections were removed in deference to AISC design provisions. 10.2.1 on design criteria for statically loaded tubular connections was revised to reference AISC 360, the AISC Steel Construction Manual, and AISC Design Guide 24 to allow design by either Allowable Strength Design, ASD, or Load and Resistance Factor Design, LRFD format. 10.2.2 refers to Table 10.2 for available stresses, except as modified by 10.5 in AISC 360. For cyclic loaded tubular connections, 10.2.3 was revised and addresses fatigue curves in Figure 10.1. A few other changes to Clause 10 tubular structures include Subclause 10.5 weld design, which was previously 9.5, was revised and now also addresses fillet welds. The previous subclause 9.6, limitations of the strength of welded connections, was eliminated. No substantive revisions were made to other parts of Clause 10. Clause 11, strengthening and repair of existing structures, was previously Clause 8. There were no substantive changes made to this two-page clause. The major change in the annexes was re-identifying them due to moving or deletion of some annexes and rearrangement of the order in the body of the code. 5 of the 8 normative annexes were re-identified. Annexes G and I retain the same identification, while Annex H on phased array ultrasonic testing is new and will be discussed in the next slide. There were no substantive revisions to any of the existing normative annexes. Annex H on phased array ultrasonic testing, called PAUT, is a brand new annex that now allows use of this technique. This is a tremendous improvement in the code. This annex is 15 pages long and is identified in H1 Introduction. It provides mandatory requirements that apply when phased array UT is used. This provides for written procedures, advanced personnel training and qualification, and calibration methods specific to phased array ultrasonic testing. H2 addresses the scope as including 3/16 to 8-inch thick steel using encoded linear scanning. Note that phased array is excluded from use on TY and K connection welds. A commentary on Annex H was also added. Only 2 of the 11 informative annexes retain the same labels as the 2015 edition. They are Annexes R and S. Again, there were no substantive revisions to these informative annexes. Annex R, Preliminary Design Circular Tube Connections, now contains preliminary design of circular tube connections that were previously contained in the Tubular Structures clause, plus some revisions to the ovalizing parameter alpha. This webinar provided an overview of improvements and revisions to the AWS D1.1 Structural Welding Code Steel in the 2020 edition. While significant changes were made to the formatting and layout of this edition, there have not been many major technical revisions made. The substantive and most of the editorial revisions have been addressed in this webinar. As always, AWS and the Structural Welding Committee encourages input from users on future revisions to this code.
Okay, Dr. Campbell, thanks so much for that great presentation. Okay, Dr. Campbell, here's your first question. I was wondering why there are so many changes in clauses and clause numbering in the edition. This is the second edition with major changes in clauses.
That's a very good question, and there are actually several reasons. First, the addition of Clause 2, Normative References, and Clause 3, Terms and Definitions, was done to meet the requirements in an AWS procedure titled TSD 1.1, Specification for the Preparation of American Welding Society Draft Standards, and to provide consistency with other AWS standards. Second, Clause 10, Tubular Structures, which was added as Clause 9 in the 2015 edition, was intentionally placed after the first 9 clauses because it references and modifies requirements in those 9 clauses. And finally, Clause 11, Strength and Repair of Existing Structures, was placed after all other clauses because it is a standalone clause separate from normal new fabrication and construction requirements.
Okay, thanks for that answer, Dr. Campbell. Here's another question that came in. Why were the inspector qualifications revised?
The requirements for qualification and certification of visual testing inspectors as well as NDT personnel were revised to provide consistency with other U.S. and international inspector qualification programs, such as AS&T. Committee members realized the need for D1.1 to be as consistent as possible in the worldwide market. Some additions were made to recognize other AWS inspector qualification and certification programs, such as the Senior CWI and AWS B5.1, and to clarify which Canadian Welding Bureau certifications were pertinent. The same is true for the visual acuity requirements, which were slightly revised.
Okay, Dr. Campbell, thanks again for that answer. And your next question looks more like a comment. I really like how Clause 5 pre-qualification was reorganized into 8 parts that follow the sequence of preparing a pre-qualified WPS.
Thank you. That is specifically why the committee changed the layout.
Okay, great. Here's another question that came in. I see that both phased array ultrasonic testing and digital radiography have been added as acceptable NDT techniques in D1.1. Aren't these methods too new to be included in the structural welding code?
No, both phased array and digital radiography have been around for quite some time and are very mature techniques of UT and RT. They both have many years of extensive use in welding, have been tested, and their inclusion in the D1.1 code was thoroughly vetted and reviewed.
Okay, great, Dr. Campbell. Here's another question. The new Table 5.7 and its associated paragraph 5.6.3 provide shielding gases that can be used with pre-qualified WSPs when using gas metal arc welding with ER705 electrodes per A5.18. But this only provides gases or gas mixtures for pure CO2, or mixtures of argon and oxygen or argon with CO2. Can I use a trimix gas?
You certainly can use a trimix gas, but you have to qualify the welding procedure in accordance with Clause 6 qualification. Use of a trimix gas for GMAW with AWS A518 electrodes cannot be done with a pre-qualified WPS.
Okay, Dr. Campbell, thanks for that answer. We've got time for one more question. In the revised stud welding Clause 9, I see that the fillet welding option no longer requires use of only pre-qualified WPSs with flux cord, gas metal, or shielded metal arc processes. Does this mean I could use GTAW for fillet welding or studs to D1.1?
Yes, provided the WPS is qualified in accordance with Clause 6, because GTAW cannot be used with pre-qualified WPSs in D1.1.
Okay, Dr. Richard Campbell, with that, we're going to wrap things up right there. We'd like to thank you so much for being here with all of us today. And we'd certainly like to say a special thank you to all of our audience members for being part of this webinar event. Take care, and we'll talk to you soon.